Hi everyone, I hope you all are doing good. So in my today's session, I'm going to cover a cloud pattern called anti-corruption layer. So let's start with it. So what is anti-corruption layer pattern? It basically suggests that implement a facade or adapter layer between different subsystems that don't share the same semantics. This layer translates requests that one subsystem makes to the other subsystem. Use this pattern to ensure that an application's design is not limited by dependencies on outside subsystems. This pattern was first described by Eric Evans in Domain Driven Design, or DDD, I would say. Okay, so what problems anti-corruption layer pattern solve basically? To interoperate with the legacy system, the new application may need to support outdated infrastructure, protocols, data models, APIs, or other features that you wouldn't otherwise put into a modern application. Okay, maintaining access between new and legacy systems can force the new system to adhere to at least some of the legacy system APIs or other semantics. When these legacy features have quality issues, supporting them corrupts what might otherwise be a cleanly designed modern application. So, I hope you people understood what is the crux of this anti-corruption layer pattern. It basically allows a modern systems and a legacy system to interoperate with each other or coordinate with each other basically. Okay, so as already explained, what particular problems this particular pattern solves, you would have seen. Okay, to interoperate with the legacy system, the new application may need to support outdated infrastructure. It may be protocol like RPCs, remote procedure calls, which is nowadays nobody is using. Okay, data models, APIs, or other features that you wouldn't otherwise put into your modern day application, which you have designed and developed basically. Okay, so when these legacy features have quality issues, performance issues, or whatever kind of issues, supporting them basically corrupts your modern implementation or the new system you have developed, right? Your intention of developing new application was to support up to the mark, up to the date technologies, protocols, all the security features, everything. But just to support some of the few features, if you make use of this kind of legacy features which have this kind of quality issues or performance issues, then it basically corrupts your entire newly designed or implemented system. So what solution anti-corruption layer pattern brings onto the table? Isolate the different subsystems by placing an anti-corruption layer between them. This layer translates communication between the two systems basically. So if you take example here, subsystem A is a modern system which implements microservices architecture, and think of subsystem B as some legacy service. Okay, so that's what they are saying. Isolate the different subsystems by placing an anti-corruption layer between them. This layer translates communication between the two systems, allowing one system to remain unchanged while the other can avoid compromising its design and technological approaches. So this diagram basically illustrates that, suppose if your subsystem B is a legacy system and subsystem A is a modern system with up to date technologies and all, but still it wants to get some services from the legacy system, then basically if we don't use anti-corruption layer, it used to compromise with that. But with the help of anti-corruption layer, that's what they are saying, this layer translates communication between these two systems basically, allowing one system to remain unchanged, that is the modern day system is not required to change in any way, while the other can avoid compromising its design and technological approach. Okay, so basically you are not required to change the subsystem B, and again you are not required to change the subsystem A. Okay, in order to compromise with its modern day design and technological approaches. So anti-corruption layer will take the responsibility of translating all these messages between these two subsystems. The diagram above shows an application with the two subsystems. The subsystem A calls to subsystem B through an anti-corruption layer. Communication between subsystem A and anti-corruption layer always uses the data model and architecture of subsystem A. Can you see that message, guys? Communication between subsystem A and the anti-corruption layer. The subsystem A and the anti-corruption layer use yeah always uses the data model and architecture of the subsystem A, which is the modern day uh, application, I would say, which is up to the mark in terms of design as well as technology. Okay, calls from the anti-corruption layer to subsystem B conforms to that subsystem's data model or methods. Here, the anti-corruption layer will take the responsibility of transforming the various messages. okay, the protocols in order to be compliant with this legacy system, which is subsystem B. So it takes the responsibility of transforming such a request and sending it to subsystem B. Okay, so that's what they are saying. Calls from the anti-corruption layer to subsystem B conforms to that subsystem's data model and methods. The anti-corruption layer contains all of the necessary logic to translate between the two systems. The layer can be implemented as a component within the application or as an independent service itself. Okay, you can implement as a component, or you can basically write a service itself, okay, which takes the responsibility of transforming these requests between these two systems basically. When to use this pattern? A migration is planned to happen over multiple stages, but integration between new and legacy systems needs to be maintained. Okay, there is a migration has been already planned for the legacy system in order to get into the hooks of modern day design and new technological practices or new technology stacks, but integration between new and legacy system needs to be maintained in order to make the new system operable. Okay, two or more subsystems have different semantics but still need to communicate. Again, both of these systems have two different semantics. For example, if you take an example of this system, it's a modern day microservices architecture which uses HTTPS based protocol, for example, but whereas subsystem B is a legacy system which is making use of remote procedure calls. Just for example, guys. Okay, so in order to integrate these two subsystems, I think anti-corruption layer will take the responsibility of receiving the modern day request message and transforming into a request which is compliant with the legacy system. Okay, so these are the two scenarios where you have to use this pattern. Most important stuff being, guys, this one: two or more subsystems have different semantics but still need to communicate. Okay, the semantics itself is completely different, okay, from the two systems. Not only the protocol, it may be the messaging model, it may be the architecture, basically it may be the functionality being provided by both of these two subsystems. Okay, when it's not applicable, when you should not use this pattern may not be suitable if there is no significant semantic differences between new and legacy systems. For example, this is a Windows Communication Foundation service. For example, say WCF service. The legacy service has been built using WCF services, which still understands the WS standard using HTTPS based communication. Whereas this is a microservices based architecture, and this also still understands the HTTPS based communication, and there is a little difference in the semantics, or you would say the models being exchanged between these two systems. In that cases, I think there is no need to put this anti-corruption layer. Okay, so that is the scenario when you are not supposed to use this pattern, guys. Okay, so that's all about the anti-corruption layer. So there are some issues and considerations, guys, I would like to highlight. The anti-corruption layer may add latency to calls made between the two systems. Yes, because of the introduction of this intermediate service or a component over here, there will be a latency between the calls made. First, the call goes from subsystem A to anti-corruption layer. The transformation and all the logic will be applied over here. The processing will happen, and then the request will be forwarded to legacy system. So there's a latency. The anti-corruption layer adds an additional service that must be managed and maintained. Yes, this will act as a additional web API or some service or a Windows service, I would say, which needs to be maintained. Consider how your anti-corruption layer will scale. You have to think about how this anti-corruption layer will scale when there is a more load or traffic on the subsystem A. Okay, because this is the ultimate application or service which is receiving the API traffic, I would say, or the application traffic, I would say. Okay, or internet traffic, that would be the appropriate word. Okay, consider whether you need more than one anti-corruption layer. You may want to decompose functionality into multiple services using different technologies or languages, or there may be other reasons to partition the anti-corruption layer. Okay, consider how the anti-corruption layer will be managed in relation with your other application services. Okay, how will it be integrated into your monitoring, release, and configuration services? How this will be integrated into your monitoring services, release, and configuration processes? Make sure transaction and data consistency are maintained and can be monitored. Okay, you have to ensure the transaction and data consistencies are maintained, and they should also needs to be monitored when you have incorporated anti-corruption layer. Okay. So, if the anti-corruption layer is part of the application migration strategy, consider whether it will be a permanent or will be retired after all legacy functionality has been migrated. Very important point, guys. Okay, you have to decide, is it going to be a permanent solution you want to go with, because you can't get rid of your legacy APIs or legacy system. So is it your plan to completely continue with anti-corruption layer permanently, or you have a plan to upgrade your legacy system services or legacy services to be upgraded to the latest technology stack with which the other subsystems are working with, or the latest design with which the other subsystems are working with? Okay, so these are some issues and considerations you have to take care of. I hope you people understood this pattern. Very simple. Okay. Thank you for listening and have a nice day, guys.